guys, welcome back. Now we're going to cover part two of the problem solving lecture. So we're going to cover shifting windows and frames. So a shifting window is basically a way of collecting a sequence of data. So a good example of this is basically this example down here where we're trying to collect the longest consecutive sequence of A's, right? So we have this sequence of A's here, which has 5 A's, and then we have this sequence of A's here, which has, I believe, 7 A's. And this is basically a window of information. So you can imagine that these highlighted A's are our window of information. And basically, the reason why it's called a shifting window or a frame as opposed to just a window or a frame, it's because this window can basically expand or despan and move around based on the information that we're trying to collect. So basically, in this case, right, our first sequence of A's, right, we basically start with this window, and then after we hit a B, we're not collecting the B specifically, but then our window will have to expand afterwards to account for this sequence of A's here. So this window, you can imagine, is basically the same window as this window, but in a way where we have some kind of mechanism that saves the maximum consecutive numbers of A's here. Now, the good thing about shifting windows and frame questions is that there's specific keywords that we could look for when we're dealing with problems that involve shifting windows or frames. So look for words like contiguous, consecutive, sequence, and continuous. So I think it's best to introduce shifting windows and frames with a sample problem. So I'm going to introduce a sample problem here. And basically, given this array of integers, I want you to return the longest consecutive sequence. So what I mean by that is 1, 2, 3, it would be a consecutive sequence, 1, 2, 3, 4, basically in numeric order, right? Negative 10, 1, 2 wouldn't be a window or wouldn't be a sequence, consecutive sequence, because negative 9 comes after negative 10, not 1, right? So in this case, we generally will substantiate a window at the first number in an array, right? And you'll see later on that basically, regardless of whether we have the largest window or not, we still want to iterate through the entire array just to make sure that we can actually see every single data point at least once, so we know that we have the right information or we have the right answer. So here we're going to start at negative 10, right? And that's our window start and end point. And then basically our current longest length is 1. We want to store that in some way because as we've seen in this previous example, our window will change in length. So we should have some kind of mechanism to store our maximum length or maximum information in this case. So our current sequence right now just is negative 10. You could imagine it as a subarray of just negative 10, and its current length is 1. So this longest length should be able to change. This longest length should be entirely based on the longest window length that we've seen previously, whereas current sequence length should always refer to the length of the current sequence. So basically, we're going to do a look ahead here, and we're going to look at 1 here, right? So 1 doesn't come directly after 10. So we want to shift our frame to the right, right? And then basically, before we shift our frame to the right, here's where our current longest length comes into play, right? We want to do a comparison between our current longest length and our current sequence length, and basically store the longer of the two. This allows us to account for several different windows that we're going to experience because our window will keep shifting in all of these questions. So now our current longest length is 1 because our current sequence length was 1 previously, and then we're going to shift our frame afterwards. So now we don't have information about our previous window, but we do have the longest length that we previously had. So now our current sequence is 1. And then we're basically going to do another look ahead and check if 2 comes after 1. And it does, so we're going to expand our window accordingly. And now our current sequence is 1 and 2, and our current sequence length is 2. But notice that our current longest length is still 1, right? And then we're going to do that again, and we're basically going to expand our frame again and look forward to the next number. 3 does come after 2. So we're going to expand the frame again and increase our sequence length accordingly. Okay, so now we bump into a scenario where our next number doesn't come directly after the last number in our frame here. So 6 doesn't come after 3, right? So basically what we have to do here is we're going to reset the frame and start it at 6. But before we do so, right, just to keep information of our previous frames, we're going to compare our current sequence length of 1, 2, 3, and compare it to our longest length, our current longest length stored from our prior windows, or the windows prior to 1, 2, and 3. So in this case, we're going to choose 1 or 3 based on whichever one is longer. We're going to choose 3 here because 3 is bigger than 1, right? So after we set current longest length to 3, we're going to move our windows to 6, right? And then we're going to continue forward. So our current sequence length is now 1, so we also reset this every time we start a new sequence. And our current sequence is now 6. And then 5 doesn't come after 6, so we're going to reset the frame. And notice that we're going to do this comparison again. So we kind of want to do this at every step. The reason why we want to do this at every step as we're resetting our window is because we want to make sure that we're storing the longest window length every time we get a new window. So imagine it like this, right? Every time we get a new window, we want to basically check and see if that previous window was bigger, if that previous window was the biggest window, right? So basically we have information of all of our previous windows in their current longest length. Or basically we only have the information that we care about, which is the longest length in this case. So here we go. So 3 versus 1, we're going to choose 3, and then we're going to reset our window to 5. And now since we're at the end, we're going to do that again, and we're going to return either the longer of current longest length and current sequence length. Because basically once we end out of this loop, right, we're not going to have this logic of code that basically resets the longest length and does the comparison. So at the end of the loop, we're just going to return the maximum between longest length and sequence length, which will just return 3 here. All right, and this is basically that in code. So find function longest consecutive sequence length takes a function array. So here we're actually doing something interesting. Here I'm marking the window, the start of the window and the end of the window using pointers, right? So basically, in the case where we're only on 1, so imagine 5 was basically over here, right? We have both our pointers, our start and end pointers of our window on top of that one integer, right? And then basically we have a variable called longest length, right? And this basically just stores the longest length. So what happens here is we're looping through the array and we're doing current number is equal to array I. So this is just the array I. Notice how I said let I equals 1 because we do instantiate everything at our zero, at index 0. So we don't have to keep track of that. And then we're saying last number in the window is basically array end of window. So it's basically wherever our end pointer is. So you can imagine in this case where we have 1, 2, and 3, end of the pointer should be pointing at 3, right? So if the current number minus 1, so if the number that comes after the end of the window is equal to the last number in the window, then we basically want to expand our end of the window, right? So you can imagine it's this case right here, where we looked ahead and we saw 3, and 3 is actually 1 higher than 2, so we expanded that window, right? So that's basically what this line does here. Otherwise, if that isn't the case, right, this is where we're going to have to reset our window, right? So we're going to first calculate the window length by doing end of the window minus the start of the window. We're adding 1 here because this accounts for basically the first item in the element. So imagine in this case where our start of the window and our end of the window, it'll basically be at the 1, 0, 1, 2, 3, 4, 5, at the 5th index item, right? So start of window and end of window here will be 5, will both be 5, right? And 5 minus 5 will give us 0, right? Where our actual length is 1. So we're adding 1 to account for that, basically. So our current window length will be end of window minus start of window plus 1 to account for that first item. And then our longest length will basically, we're going to reset this variable here, longest length, and we're going to make it the maximum value between our current window length, which is window length, and our longest length. So between itself and the window length, right? So the longest length that I previously stored and the current window length. And then basically here, we're going to reset our window, right? So we're going to reset the start and end of our window to I. And remember, we're resetting it to I here because I is basically always going to be ahead of start of window and end of window because we started at 0, right? Right. And then basically once this loop ends, I increments. So this basically will be, let's say we're in this case where we actually reset our window. So 6 and 5, right? Since we're setting it at the end of our loop iteration, we're setting both start and end of the window to 4, and then we're setting both start and end to 4, and then we're basically incrementing I. So I is going to be 5 in the next iteration, right? So basically these will always be behind wherever our current number is. And then basically here we just want to return the max of the window length and the longest length, right? There should be a comma here. There actually is, but it's a little bit hard to see. But yeah, so does anyone have any questions about that? Okay, cool. So now I'm going to introduce a problem um, for you guys to practice. And basically, just to get you guys started again, especially for those in the VOD that may not have watched part one, but basically, I want you to open the clone GitHub repo, npm install, npm run tests, and then write all your code in test.js. If you haven't cloned yet, look in the description or in our Slack group. And the function that you basically want to write all your code in is going to be called largest continuous sum. And again, it should be in test.js. Okay, so let's talk about largest continuous sum, which is the problem I want you guys to do. So I want you to write a function called largest continuous sum that basically will take an array of integers and it returns the largest sum composable with contiguous integers from the array. For example, if I gave you the array 1, 2, 3, 4, right, the largest contiguous sum would basically be a window of information of 1 plus 2 plus 3 and 4, right? So 1 plus 2 plus 3 and 4 will be 10. The largest continuous sum in this case, where we have negative 1, 2, 3, and 4, will basically just be 2 plus 3 plus 4, because if we include this negative 1, our continuous sum would be less, right? So this should return 9 and not 8, right? Largest continuous sum here should return 20, right? Because basically our largest sum here, the largest possible sum is 20, despite all these other numbers here. And then our largest continuous sum for basically this example here would basically just be, it would either be this window or this window. But in this case, 5 plus 5 plus 4 is 14. So we're going to return 14. And this will return 13. So this will take precedence over this window, right? So you guys can see that basically if we have contiguous, we do want to think about windows, right? And also notice here that I'm not asking you to return the subarray. I'm just asking you to return the actual sum, right? So it should return 14 instead of this subarray here. Okay, and just for some hints, you'll probably need a way to store the sum of the current window. So imagine, think about our last example where we were storing the current length and the current maximum length and the current length, right? That's kind of important. You'll see that this becomes important later on. You'll probably also need to hit at least O of n time because you need to visit every single number at least once, right? Even if you do know that you have the maximum window, your code doesn't know that. So it's important that you go through every single item in the array just to make sure our window is correctly the longest window. Also, this is really important. So we had a clear idea of when we should reset our head in our previous example, right? So in this case, think about when we should reset the head of our frame in this scenario, right? It's really important that we understand when we reset the head of our frame. And a common misconception that a lot of people think of is that we shouldn't reset our frame if we have the maximum answer, which isn't true. You should have a way of storing your maximum answer while also having a way to reset the frame anytime you can start a new frame, right? So in our previous example, even though we had our longest frame, we still reset the frame and started new frames, right? But we kept the reference of our longest current frame inside a variable, right? And this is important because we don't know if a frame in the future, so let's say we didn't exactly know how our input would looks like, right? We don't know at this point in time that this is the longest frame, right? So we want our code to create a new window every time it can create a new window, but it should also store the previous longest length, right? So in this case, you should know exactly when you should reset your frame. And think about this case. This is a good case for thinking this through, right? Basically, we'll probably have a frame at 1, -2, -2 you probably want to 1 plus -2 is 1, right? So your frame actually decreases here. And then 3, 4, and 5. So your frame is probably going to be 3, 4, and 5, right? So your head should reset somewhere here to 3, right? And then it should collect 4 and 5. And then reset. It should basically reset between these 2 points, right? How do we get our frame to shift to only have 3 and 4 and 5? And what conditions do we have to use to shift our frame, or basically reset the head of our frame, right? So basically, if you guys have any questions again, feel free to raise your hand and let me know. I will be walking around. Other than that, go ahead and try the question out. All right, guys. We're back. Let's go over the problem now. In For the sake of time, I'm just gonna go over this problem because we only have around 20 minutes left. So I'll just knock this off real quick, and then you guys can basically ask me any questions as you see fit. So here we're gonna start off by basically talking about how we should approach this in a whiteboard solution, right? So the first thing that we should start off with a good example, right? So it should be a relatively short input. That makes it really easy for us to whiteboard it out and really think about how the solutions should look like and not get lost in basically trying to run through every single iteration and make sure all our all of our iterations are correct in the longer input. Next, we should also think about something that has negative numbers because this forces us to move our frame. If we only had positive numbers, we can basically just add every single number in our array, which wouldn't necessarily be correct. Correct window is not at the edges. So this is a good example because we have to move our frame to the center, which makes it a little bit more difficult because that forces us to have to actually shift the frame, right? So this would be an example of a good input where our answer is 3 and 4, which is somewhere in the middle of our input and isn't at the edges. And we also have negative numbers here. So these negative numbers, as you can imagine, kind of like force us to shift our frame as well. So we're going to work through this example, and we can basically have multiple frames in this example. Think of it as subarrays. The reason why we're going to have track of multiple frames and why we're going to reset our frame multiple times is because we want to make sure that we get the maximum sum of all the possible subarrays inside of this question or inside of this input, right? So since we're trying to keep track of multiple frames at a time, right? We want to create some sort of maximum variable that stores a maximum sum or maximum current sum and also a current sum. So we're going to create variables to store our current frame sum and the largest frame sum. Okay, so we also want to start at the beginning because let us basically cover every single number in our array. And okay, and then here, basically, since we're starting at our initial value, right? You can either start your largest sum at at negative infinity, so it basically always gets replaced, or you can just start it at the first number in the array. And the advantage of doing the first number in the array is that we can basically just start a loop iteration at the 1 index instead of the 0th index if we do that, because we know our window already accounts for our first item. So let's walk through this example, right? So basically, we're gonna basically going to look ahead and add -2 to our sum. So our current frame sum is -1, but our largest sum is still 1 because 1 is greater than -1, right? So basically, we want to think about when we're going to shift our frame. In this case, it's not really necessary to shift our frame if we bump into a negative after, or if the next number in the array actually decreases our current sum. The reason why we don't have to necessarily do this is because we already have track of our largest sum, right? So we don't necessarily have to account for this, right? Now, when we hit 3, this becomes an actual issue, right? So 1 and -2 wasn't an issue because we already stored our longest sum as 1 before we hit -2. So that -1 would have never overwritten our current largest sum at 1. But now once we hit 3, right, 1 plus -2 plus 3 becomes 2, but that isn't quite correct, right? Because 3 is larger than 2. So including these two numbers would not be beneficial to our largest sum. So this is a scenario where we probably have to reset our window head because we lose track of 3 here. So if we increase our frame further from this, even though our frame sum is technically increasing, we lose track of 3, right, as our highest start point. So basically what we want to do here is once we hit 3, we want to reset our window at 3. So basically now we know the condition where we need to reset the frame of our window. We basically want to reset the head of our window in the scenario where basically the current number is greater than the sum of the current number and the current window, right? So since 3 is greater than 3 plus -2 plus 1, right? Or 3 is greater than 2, we want to reset our head at that at 3 because 3 is greater than basically 3 plus the previous window. So now our current largest frame sum is 3 because we reset our head. So again, anytime we reset our head, we're going to calculate a new maximum sum. Okay, and you can think about it this case as well. So if we reset in the case where 3 where we're resetting based on if our current number is greater than our current number plus the previous current window. If we started at a negative number, so imagine if we just had -2, since we know that -2 plus 3 is less than 3, we would reset our window at 3. So resetting at this situation makes a lot of sense, even with edge cases, right? Because our window will always reset as long as our current number is greater than the previous window that we currently have. And then now our current frame sum is 3, and our largest frame sum will be 3 because 3 is greater than 1, which was our previous largest frame sum. Now we move forward and we're going to tack on the 4, right? So since we're adding on the 4, our current frame sum increases 7. We don't have to reset here because 4 is less than 3 plus 4, right? So 4 is less than itself plus our current frame. And then our largest frame sum becomes 7 because 7 is greater than 3. And then we're also tacking on -2. We don't have to, again, we don't have to reset our sum here because we already kept track of our largest current frame sum. So we still have 7 even though this current frame is 5, right? So we don't really have to reset here. It would just be extra steps. And this is basically that solution in code. So we're starting at the first number in our array. So our current sum is 0. Our current maximum sum is 0. And then we basically start at I equals 1 because we already have track of our 0th item. And we're basically setting this variable so it's easier to read. So current num is equal to array I. So that's just whatever number we're currently on in the loop. And then we're basically just saying current sum is equal to the maximum between the current number or the current number plus the current sum, right? So this is a scenario where we're going to reset our window, right? Where we're going to check if we need to reset our window. So if we do reset our window, right, we're resetting our current sum to current num, right? And then if we don't need to reset our window, we can just add it, right? So in this case, we're just adding our current num, which will be 4 plus 3, so that'll just be 7, right? In the case where we're resetting, however, we're going to make our current sum just our current num. So our current sum, which was this frame before, just becomes 3 because that is where we want to reset our window. Okay. And then current max is basically just at every step we're just going to check if the current sum is greater than current max. If it is greater than current max, right, then we want to set our current max equal to current sum, right? And basically here we're just returning current max. Okay, does anyone have any questions for this problem? Okay, awesome. Okay, so unfortunately we didn't get to cover the sorting methods today, so I will cover that at some other time in a VOD. That will be posted on probably YouTube. So